the files that you have submitted. So let's start. Okay, Marcus, are you there?
Yeah, I'm here.
Okay. So this is the other house. So we have you're working either on the Wolfstone house, or this, what's the name of this? By the way, what's the name of
Oh,
this?
sorry, it's the
Yeah,
Trubeck house.
Trubic house by Robert Venturi. I think he's the architect. Yep.
Yeah.
Well, this guy Venturi is not my cup of tea, but anyway, he's a good architect. But I wouldn't name this one among the 10 best architects in the 20th century. Anyway, he's there, and I think it's worth analyzing because it looks like this is Nantucket, I think, in Massachusetts, and it looks like a traditional American architecture. Okay. I like this. I like the site plan. It's quite good. The only, because you have included the solar path, here we have the north, south, east, west, so it's perfect. And you have analyzed it. I like this because I can understand that there are different things here. You have this dashed or dot and dashed line. I assume that it's the limit of the site. I don't know. You have here, I don't know if this is a road or a walkway, but yeah, I understand that there are different things, or this is the driveway. I don't know, but I can understand that there are different things here, and I assume that the round or the circles are trees. The only thing you can, yeah, because I assume that this is the house, the Trubeck house, but it should be like, I don't know. The house is more important than trees. And there are two houses here. Yes, there are two houses. Are you analyzing both of them, or just one?
Just one.
Just one. Okay, so which one? This one.
Yeah.
Okay, so at least you should highlight this. I know, maybe a thicker line or a hatch, something to let us know that, yeah, there are a lot of information here, that the most important thing on this site plan is your house. Okay, so just think about it. We have the ocean and we have the road. Okay, I like this site plan because we have a lot of information here, and you have a legend. Okay, so everything is perfect, but just highlight the house you are working with. Then we have this. I like the idea that you have included the north sign or the north arrow, even in those plans. That's good. The only thing that it's not there, it's a graphic scale. You have a scale here. It's a 1/8.
Yeah,
One.
sorry. It's not to
Yeah,
scale.
because if I had the paper, I could take a scale and measure it. That in a PowerPoint presentation, this is not relevant. It's better a graphic scale. So if you don't mind, just include it. Oh, and then for the elevations, okay, for the elevations, you don't have any sections here, so only elevations. Okay, we're working with elevations. I think, again, you have this scale here. We can have a graphic scale that will help, but if we're working with elevation, at least we need to know the total height of this building. Okay, so this is relevant. Okay, and I don't know what the height is. No, let's say 30 feet. I don't know. But this is relevant. And then there's another good way to work with elevations. We can work with levels. Okay, so levels are triangles. So these triangles are useful because here we can, if we work with a dashed line here, for example, like this. Okay, so having levels, it's useful For example, that would be level 0. Okay, so always the ground floor, it's level 0. Then if you have some steps to go up, and I think you have yeah, you have 3 or 4 steps to go up, then the second level would be that one. Okay, so there's another level here. How much? I don't know. It's 3 feet, I don't know, whatever. Okay, but this is the second level. Then the third level should be the floor level of the second floor. It can be level 12 or 13 or whatever. And finally, we have the total height of the house. So when we are working with sections and elevations, this is useful. Okay, so we need to know where the 0 level is, and then we need to go up, and we can go down. I told you that we need a basement, so you can have a, yeah. Is this a basement or?
No, it doesn't have a basement.
Okay, so if you don't mind, for this exercise, you can have like a basement here. Okay, so if we have a basement with levels, we can do the same. So if there's a basement level here, this can be negative 10, for example, or negative 8, or negative 5, or negative 6, or whatever. Okay, but if we work with levels, I think it's easier to understand and then the total height of the building, it's fine. And then you can add the graphic scale, so that would be great. Okay, but working with levels in sections and elevations helps a lot, and so we can understand the height of not the height of the house, but the height of different levels and the floor. Yeah, and it's important we always have these levels where the floor is. Okay, so it's not the bottom of the slab, it's the top of the floor, of this floor. Anyway, I'll show you more examples. And then you try this. Okay, I like this. You have worked on that detail, and this is fiberglass 10 inches, which would siding. So okay, when we're working with this, it's useful as well to point out what outdoors and indoors is. Okay, that's useful. And then, so this is the wall detail. Is this a plan view or is it a section?
Section.
It's a section. Okay, so we have this element here. What is this? This is the framing. This is something we have to understand. Let me go over. Okay, most likely that will be the detail of that roof. Yeah, I think it will be something like that. So we can, yeah, we can go with it. But here, this is a section. Okay, that's fine. But we have this element here. So what do we call this element? If we have a frame construction, this is the typical construction of New England. Okay, so you will find things like this. So it's a wooden frame, and then it's filled with thermal insulation, and then we have an internal finish and an external finish. But we have a lot of vertical elements, and probably we'll have some horizontal element as well. Let me see, we have a picture, yeah, like this. You see that we have vertical elements and horizontal elements. What we are looking at in this section, okay, yeah, well, it's always like that. If we look at this, here we have the external finish, we don't have the internal finish. So there are vertical elements and horizontal elements like that. So it's a frame. What we are looking at this, so this is one of the horizontal elements. Vertical elements are stats. Yeah, there you go. Okay, so the vertical elements are stats. And the horizontal elements, they can be sealed if they are related to a window. Okay, I don't think if we have a horizontal element that goes from here to here, it's not a seal that's related to the window. Mm, okay, but those are frames. And as you can see, we have stats and we have a space that is filled with thermal insulation. So we can have the same concept that we had with roofs. When we were dealing with roofs, like this, we were okay. We mentioned rafters. Okay, so these are rafters. When we have a roof like this, we have rafters. When we have a floor, a horizontal floor, we have joists. And when we have vertical elements, we have studs. Okay. Uh, so we mentioned rafters on the first assignment because we were working with a roof. But now if we're working with a wall or we're working with a floor slab, we can either have joists or studs. Okay. So here on this detail, we have those elements, but for sure we will have vertical studs. Okay, how can we deal with this? Okay, here, there you go. So this kind of wood frame construction, there will be studs, vertical elements. There will be another stud here. And then here in the middle, there will be thermal insulation. There you go. Okay, so this is a thermal insulation panel, can be fiberglass, fiberboard, whatever, between two studs. And this is wood. Okay, so that stud is made of wood. So what happens here? So there will be a U value through the stud, and there will be a U value through the thermal insulation. And finally, we will have to calculate the U average. Okay, so the U average would be the U value of the stud times the area of the stud plus the U value of the thermal insulation times the area of the thermal insulation divided by area of stud plus area of thermal insulation. Dimensions, I think in a traditional wood framing, it's always 2 and 14 inches. Okay, so this is going to be always 2 plus 14, and then the U value through the stud and the U value through the thermal insulation. This is what you have to calculate. Finally, there will be an internal finish. It can be drywall or whatever. And then there will be an external finish. We can have this siding. Okay. So this is the siding. and this is the drywall. The section, if we look at the section, is what you showed in that example. There will be thermal insulation. Here, there will be drywall. And here, what we can see in your detail is that we have horizontal elements. Okay, then here we continue with the thermal insulation, and we continue with the thermal insulation here, the drywall. So those horizontal elements, it's to make the frame, to provide the frame wall with stiffness, okay? Because if we don't have a horizontal element, probably they will bend. So that's why we need these. These are not studs, they are not rafters, they are not joists, what they call it, I don't know, horizontal wooden elements. And then I think I would leave like air cavity here, and then I will start placing the siding. Okay, so this can be an air cavity. And this siding will be connected to well, something that is here. Okay, so there will be another vertical rafter, and then we can nail this siding to that rafter. But that will be an air cavity. So at the end, we will have the drywall. The drywall, it can be ½ inch. This, it can be either 6 inches or 8 inches, depending on the thickness of the rafter. This is a structural decision. 6, it's for non-structural walls. 8 is better for the structural walls. I don't know, but this is a structural decision. Then we can have an air cavity, and this air cavity can be 2 to 3 inches. And then this siding, it's again ½ inch. What do we do when we are retrofitting a house? So this is the traditional, well, the traditional. If we had thermal insulation, it would be great. Sometimes we don't have even thermal insulation. If we are retrofitting a house that was built in the 50s or in the 40s, we don't even have this. But if we have this thermal insulation here, a good way to retrofit this without being aggressive at all is to remove the siding, those elements, and we can fill this air cavity with thermal insulation. And then we place the siding again. So we are increasing this thermal insulation by 3 inches. This can be a rigid insulation, EPS, that is good against, it works well against water. And then this can be, this thermal insulation can be fiberglass or fiberboard. Okay, so I think this is a good option for this kind of walls. And I think that the Venturi's house, it's a traditional North England or New England, sorry, house, and most likely it will be something like that. Okay. So let's go back to, yeah, to that detail. Okay, so here we have another OSB board, 1 inch, the drywall, yeah, why not? So adding layers helps. And the wood siding, I don't know, I would add here like this air cavity or air chamber, and that will be better. Anyway, this is good. because with 10 inches of fiberglass, you don't meet the passive house standards. So by adding like a couple of inches, 2 or 3 inches of extruded polystyrene or EPS outdoors, you will be above 50. Okay, so that's a good option. And then for the roof, you are above 50 because we have 12-inch fiberglass. By the way, you have written here fiberglass and here you have written EPS. So it's either, I think this is the EPS that can be 2 inches. And this can be,
Yeah, I forgot to change it.
yep, this can be 12-inch fiberglass or fiberboard. Well, glass. Fiberglass. Okay. So I think I would do this because we always have to do this before and after. So you can use here, I would do, okay, this is before. We can have 8 inches of fiberglass, and then you can have 8 inches of fiberglass plus, let's say, 2 inches of EPS, and then you can add here another layer. Okay, so these 2 inches of EPS will be here. No, sorry. Oh yeah, here, because this is outdoors. Yeah, this is indoors. Okay, because we always need a before and after, so that would be after. Okay, so it's before the improvements and then after the improvements. So for the roof, we should do something else. So this can be after. You have 12 inch of fiberglass and only 2 inches of EPS. And before, you can get rid of this and you have only, let's say, 10 inches of fiberglass. Okay, because we need improvement. This is 50, so it meets the passive house requirements. But first, we need an option in which we don't meet the passive house requirements. So that's the difference between the before and the after. Okay, but okay, it's good. You have all the information here. But for the final report, yes, we have to include the first option and then the second option with improvements. And the improvements on roofs and walls, the only thing we can do is adding more thermal insulation. Let's move on. Hannah, oh, I can't work with this. Dorza, are you there?
Yes, I'm here.
Okay. Well, this is interesting because this is your design 2 project. I like the site plan, but your building is not here. It's not in this site plan analysis.
No, it's not. This is just the existing condition of the site.
Ah, okay. Well, at the end you should add, because well, we have the site plan here, but I think this is nice. And if you add here at least the shape of your building, I think it will help understand what you have done.
Okay.
But I like this site analysis. We have the north sign, and well, here you have your building. Usually when we are looking at the site plan, we have the roof plan of the building, because here you have a lot of walls and we can't tell what this is. Okay, so for site plan, use the roof plan of your building.
Okay.
So this is well, we are focusing on this building because this is the unheated storage, but you have, so this is the cardio.
Yes.
Okay, so is this the first floor and this is the second floor? So on the first
Right.
floor, we have the unheated storage, and on the second floor, we have this. Okay, so this we have a heating system here. Okay,
Yes.
let's do it. Um, we don't have the we need the north arrow somewhere. Okay, so even in plan you can tell me, but you have this plan, so you can, yeah, here I have the north arrow. Every time we draw a plan, we need the north sign. Okay, so it's, and we need the graphic scale. So here I'm missing the graphic scale because I don't know how big this is. What is this, 400 and 4,000?
That's the square footage of
Ah, the square
each
footage.
room.
Okay. Anyway, we need the graphic scales or rough dimensions, at least the external dimensions of this. We need
Yeah, that
something.
line on the bottom is the graphic scale. I just forgot to add the numbers are underneath the picture right now,
No?
so I made a mistake.
Okay, so let's bring out the numbers and it will be better. Yeah, oh no, I see that this is 0 and this is 30. Now, yeah, I can tell now. Okay, make it, probably you use the white font,
Yes.
and yeah. Okay, elevations. Here you have levels. If you're working, this is Revit, by the way. Is
Yeah, it
it?
is. It is.
It is. So if you are working with Revit, you have levels. Okay, so it's automatic. It's not, well, usually when we're working with Revit, we tend to hide the levels, or at least make it different, because at the end we will end up having a lot of lines and it's kind of confusing. But this is what I meant when I was talking about the other project about levels. Yeah, so this is level 0, then we have level 4, and then we have level 16, or yeah, 16. Is this glass? This blue,
Yes,
and this is glass as well?
it is.
Okay, we have to be careful because you have a huge area of glass. Okay, we have to analyze this. I don't mean it's right or wrong, but at least we have to analyze these. And these are the 3D views. Okay. Well, so if you email me with the Revit file, I think I can help you work with this, because it's we can't have a glass like that. So we need a glass structure. If you have attended Matthew's presentation, if we are working with curtain walls, we need mullions and transoms. So we can't have a glass like this.
Yeah, I'm
So
gonna add those to the structure. It's just very simple right now.
yeah.
That's where I am.
So if you add the
Mhm.
structure, it will look better, because now it
Yeah.
looks like a huge opening. But if you add the structure here, it will look better. And then here, okay, I'm not talking about the project, but well, we can make it better. If you don't mind emailing me with the Revit file, I can help you out. I can record something and send it to you. But let's move
Okay.
on. So you have used this, okay? So this is what we needed: U value, very high U value, and then we needed details, wall details. Okay, you have the air cavity here, and we have the plywood. We don't have thickness here. You need to add plywood, ½ inch, or EPS 6 inches. Okay,
Okay.
it's there, but it's not in the drawing.
Mhm.
So here we have the, okay, so if you don't mind, add this in the drawing and it will look better. We have this, okay. Yes, here you have added the thickness, and I think it works better now. You have our cavities. Yeah, it looks like a detail, so it's good. And here we have the foundations.
I
Okay.
wasn't sure how to do the floor U value when I don't have a basement, so I just did it like walls.
Yeah, so in this exercise, you have to pretend that you have a basement. Okay.
Okay.
So let's make it deeper and just, or if you want, well, oh no, let's do this. Since this is your design too. Let's make it as is, but email me the Revit file and then I can use Revit. I'm not teaching Revit in that course, but if you have the Revit file, I can help you calculate the U value of the floor with Revit, and I think it will be useful.
Okay.
Okay, so let's do this. Email me the Revit file, and then I'll show you how to do it. This one, Amanda. Okay, we have a site plan. I like this. Amanda, are you there?
Yeah, I'm here.
Okay, so is this a hand drawing or is it a software or what is this?
It's a hand drawing.
Okay, great. No, I think it helps me understand the building. Here you have the site plan. Okay, we don't have, well, we do have the north arrow. Sorry, we don't have the north arrow here. Okay, so if you don't mind, add the north arrow, a graphic scale. Try to add levels, especially for sections. Okay, so try to add levels, as I explained before, because it will help understand. And for the elevation, at least we need the total height of the building. And here you have the details. Siding, air cavity, fiberglass, air cavity. Okay, so I think this is the first option. The U value okay, the R value is 45. That's fine because it's not 50. So for the second option, you can fill those air cavities. You have an air cavity here and another air cavity there, 2 inches and 2 inches. You can fill the outdoor one with EPS and the indoor one with fiberglass. Okay, so this is the first option with air, and then the second option, it will be EPS here and fiberglass here. So you will increase the R value and decrease the U value. Okay, so that's fine. And then for the U value, what have you done? EPS 6 inches and 6 inches of rafters. Okay, so again, for the first option, try to change this, try to do this with 2 inches of EPS. And for the second option, try to do it with 6. So you have already done it with 6. Okay, so with 6, you have a good R value. But for the first option, I want something worse. Okay, so if you don't mind, include another table, the before table, with 2 inches here and 2 inches there. And then the after table would be 6 and 6. Okay, but it's fine. What about this one? Okay, Craig, I'll go over it. We have a site plan. Again, this site plan can be better because now I know that you are working with this house, but I don't know, it should stand out from the rest of the lines. Okay, so you have the lines here, so this should be something different because you have hatched this. I assume that the hatch is the green area or whatever. So this should be something different, the house you are working with. For the floor plans, again, we need the north side. Do we have a north? Yeah, well, it's here. We need the same north arrow here on the floor plans, and we need a graphic scale. Okay, you have dimensions here, that's good. And you have a 3D picture, great. A 3D model, I mean a physical model. By the way, just an advice, if you take pictures of your 3D model, try to hide the bed, okay? So it's
okay.
Just place here like a blank paper or a black or something, but just a piece of advice. And for this, we have, okay, so this is a good value to start with because it's pretty low. And the second option, you can fill these 2 air cavities. The same thing I told Amanda, that you can fill those cavities with thermal insulation, EPS outside and fiberglass inside, okay? So you will end up having 5 more inches of thermal insulation, and then this number will increase So that's a good option. So this is a good option for the before. And now you need the after with 5 more inches of thermal insulation. For the roof is the other way around. This is a good option for the after. Okay. And for the before, this should be 2 inches of EPS.
Okay.
Because this value it's good enough, but we need a first option that it's something that it doesn't meet the passive house requirements. And then for section 2, this is for rafters. Again, you have to, this is the after solution, and then we need the before one, and then you have to calculate the average. That's good. And since you have this, we have to make the most of this 3D model. Okay, so you need to take better pictures, and we can do the solar analysis with the 3D, with this 3D model.
Okay.
Let's go to this Fisher House. Whose presentation is this?
Mine, Rebecca Williams. Sorry.
Okay, so please write your name. We have this. You have selected the glass. You have all the, well, this is something that you should include. This table with this schedule of windows, especially the area of windows, walls. Okay, that helps me a lot. So if you haven't included that, the previous students they haven't included this table. It's helpful if you include this. So here we have the second walls, and here you have the wall analysis. Okay, so that would be great for the before option. And I think now you can do this. You can have an air cavity here. Air cavity, let's say 3 inches. And then you can fill this air cavity with thermal insulation for the after. Okay, so that would be thermal insulation, let's say EPS. Okay, and because the first value it's 31, so it's good, but then this one should be above 50. Okay, so
Okay.
this is what you have to try now. If 3 inches is not enough, then you would need 4 inches. I think 3 inches would be more than enough. But the second option, or the after option, should be above 50, the R value. Okay, and then okay, that's great. We have the soil, and again, this is the basement analysis. This is before. Now you need to do the same with the thermal insulation, because I think those values are without thermal insulation. And now you have to do the same, extending. Yes, I think this is, that's great. So you can include the air cavity here, and finally you can extend the thermal insulation until the footing, and that would be the after option. Okay.
Okay.
So great.
Thank you.
The next one, Cyrus. It's a weird house. Okay. Okay. Well, again, north sign, it's there, a graphic scale. For the sections, please add levels. It will help us understand where what the height of this house is, if you add levels on the first floor, the second floor, the attic, and then the total height from the floor to the top of the roof. U values of the roof, you have calculated something, roof. Okay, for the roof, we need, you have the rafters, but we need the section through the thermal insulation. Okay, so this is one of the tables, but we need another table for the roof, and then we need to calculate the U average. And for the walls, I think this is good for the before option. Oh, this is a PDF. I can't edit it because it's 38. But then you will have to increase the thickness. By the way, this is wrong. The thermal resistance. Oh, yeah, no, it's not wrong. Okay, so if you increase this thickness and the next, the following option, the after option, it's 6 inches instead of 2, that will be above 15. Okay. Try to include again what Rebecca did before. Try to include a schedule with the window, the wall area, the roof area, because that helps me understand. And you would need it for the next assignment, because on the next assignment we will be calculating the thermal loads. Now we have calculated the U value, but then we will have to calculate the thermal loads, and you will need the wall area. And the Wolfson trailer house. Okay, I like it. Well, some of you asked me what happens with this house, because is this a basement? Is this a, I think, yes. So here we have the explanation. So part of this, well, it's not. I thought this was higher, and part of this basement was like buried, and other part wasn't, or was like this. Well, anyway, you have to consider this as a basement, and I think you can consider that this wall is buried or is underground, and this is not underground. So you will calculate this wall as the first floor wall, and then you will calculate this as a basement. So imagine that this is covered with soil. All this is covered with soil. So this is a basement wall, and then we can calculate this basement wall as we have calculated others. But this is not underground, so you have to calculate this as this wall or any other walls that we have calculated before. Okay, so if this is your basement, so imagine that this wall is buried or it's underground, and the rest of the walls are not underground, and then that's it. But you have done this, you have already calculated the heat loss. Okay, so this is due, or that was a requirement for next part, but you have already done it. Okay, I'll go over it, but I like the details. I like it. Kaylee, okay, you are working with this north sign, graphic scale, nice site plan, and you are working with this. Okay, so this is what I was, yeah, I think okay, so this is underground, so you can calculate this part of the basement underground, and then the other part is not underground because we have a slope going that way. It's fine. Trubeck. Okay, I see that you are copying those details. That's good. Well, we have to talk about this. I can help you with this because it's not, it seems that you don't understand what this is, and it's understandable. So I'll help you out with this detail, with the connection between the wall and the roof. And you have selected another U value. Okay, great. Well, I think we are almost done. We have this. Okay, that's pretty good. And okay, Shlisha, are you there?
I am. I'm here.
Okay, so just a question: is this Revit or is this SketchUp?
That's SketchUp.
SketchUp. Okay. No, that's great. Well, if you're working with SketchUp, so let's do this. If you were working with Revit, I can help you calculate this with Revit, but SketchUp doesn't have a module to calculate thermal loads, so we will do it the traditional way. But it's pretty good. Okay, so we are done here. I will post this lesson, and because the same comments apply to all the students. So if you haven't included a schedule with all the wall areas, do it, and you have to improve the detail, do it. And if you want, if you don't have the option of before and after, you can do it again. But I mean, this first part is just complete or incomplete. So everything that we have seen so far is complete. And I will post the second part of the assignment this afternoon or tomorrow morning. Okay, see you on Monday. We run out of time. See you on Monday.
See you
Thank
on
you.
Monday. Thank you.
Bye.